Now we're going to look at patterns in reactions. So some reactions are very similar and we can categorize reactions. Just like in the elements, we can categorize metals versus nonmetals. In reactions, there are different types of reactions. So let's look at these three reactions. What do you see? So you should see that we have, on the left-hand side, we have one reactant. And then when we look on the product side, we have more than one product. So this is a special reaction called a decomposition reaction. Okay. In a decomposition reaction, it has a general formula of AX yields A plus X. So we have a compound that is breaking down into simpler substances. So it might be their elements, or it might be a compound in an element, or it might be even be two compounds. So anytime you have only one reactant and then you have more than one product, that is called a decomposition reaction. And a good example of this is water. We can take water and split it. So by just adding a little bit of electricity, we can form hydrogen gas and oxygen gas. And let's quickly balance this. So this is liquid water that we're starting with. And to quickly balance this, I need to put a 2 in front of here and a 2 in front of there. Okay, so this is decomposition. So here I have 2 water molecules, and then I end up with 2 hydrogen gas molecules and 1 oxygen. So, but the pattern is still the same. One thing right here, and then here it's split up into simpler substances. All right, let's look at this pattern. Again, you don't need to write this down. I really just want you to take notice of what do you see as being similar. And again, they might not be balanced. It's because I don't want the balancing numbers to distract you of what you see the pattern. All right, so what's the pattern? So here we have 2 things that are coming together to make one thing. So we end up with 2 or more reactants, and we get only one product. So this is a special type of reaction called a synthesis reaction. It sometimes is called a combination reaction too. And the general formula here is you have A plus X, and then they bond together and make AX. Your example here, we can take copper metal. So this is just the atom. And I can take sulfur. This is just the atom also. And I get copper 2 sulfate. So, excuse me, sulfide. So copper 2, so it's a plus 2 charge. Sulfur has oxidation number of -2, so I can just stick those together. So notice I still have to use oxidation numbers. And then this is balanced. So this is our third type of reaction. What is the pattern? So if you notice, we have an element plus a compound, and we find that the element kicks out the metal of the other compound. So they trade places. So we end up in this first one having a copper atom, and then silver's in the compound, and now we have a silver atom and copper's in the compound. So this is a special type of reaction called a single replacement. Sometimes it's called single displacement. Either one is correct, okay? And so I abbreviate this as either SR or SD. So in this one, we have to go back to, and I haven't been using the dance analogies with the other one, but here we have a couple is dancing happily, and a guy cuts in and leaving the original guy who had a partner out. Okay, so again, you have an element plus a compound, and then the element and the cation are going to switch places. Okay, so we end up with a new compound and a new element. So here's your example here. We have aluminum metal, and it's just the metal atom, so I can just write Al. And then we have copper 2 chloride. So copper has a +2. Chlorine is a -1. So that means I need to have 2 of those to give me that -2. So I'm going to write that CuCl2. Let me just bring down that aluminum. And then we have aluminum chloride. So aluminum with a +3, chlorine is a -1. I'm going to have 3 of that chlorine, so AlCl3, and then I just have plain old copper metal. Okay, so this is not balanced. Everything looks balanced except for the chlorines. I have a 3 here and a 2 over here. So what number do 2 and 3 go into? They both go into 6. So we're going to bring the number of chlorines on each side up to 6. So I'm going to put a 2 in front here and a 3 in front here. This messes up my metals, so I need to put a 3 in front of the copper and a 2 in front of the aluminum, and now it is balanced. All right, this is our fourth type of reaction, so see if you can find the pattern. So when you look at this, you're going to look the cations are going to switch places, okay? So the first ones are going to switch places, and so with the last one that we talked about was single replacement, this one is called double replacement. And again, it's called double displacement too. So if we do the dance analogy, we have two couples dancing and then they just trade partners. So your cations are going to switch places. You could also look at it, your anions are going to switch places. It's the same thing. So we end up with a compound plus a compound, we get two new compounds. And these are often called precipitation reactions. Sometimes they're also called acid base reactions or neutralization reactions. For right now, just call them double replacement. So to write these, you need to go and use the oxidation numbers because there's metals here. So sodium is a +1. Carbonate is a -2. So I'm going to have 2 sodiums for every carbonate. Okay, so notice again, I don't do this in one step. I do it in 2 steps. Cobalt is CO, and that tells me the charge. It's a +2. Nitrate is a polyatomic ion. It ends in 8. So look at your polyatomic ion chart. So I'm going to have CO, and I have to have 2 of these nitrates. And then I have cobalt 2 carbonate. So cobalt is right there, and carbonate is right there. And notice that one's a +2 and one is a -2. Always write your cation first. So CoCO3. And then sodium nitrate is a +1 and nitrate is a -1. So just stick them together, NaNO3. Let's see if this needs to be balanced. It looks like there are 2 sodiums here and only 1 here, so I'm going to put a 2 in front. And that gives me 2 nitrates, which I have right there, and 1 cobalt on each side and 1 carbon on each side. So we're done. Just putting a 2 there balances it. So in this one, this is a precipitation reaction. This actually forms a solid. So that is the solid that's formed when this comes together. All right, so this is our last pattern. This is probably my favorite type of reaction. See if you can find the pattern. This one is a very specific reaction. Notice that you have the same product. It's always carbon dioxide and water. And notice you always, 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 always have oxygen on that side. Okay. And then even what we begin with, it has carbon and hydrogen. These are called hydrocarbons. And these hydrocarbons, they can have oxygen or they cannot have oxygen. But anyway, you take a hydrocarbon and you react it with oxygen, and that yields you carbon dioxide and water. And again, these aren't balanced, but this is the pattern for combustion reactions. So I think a lot of students take chemistry because they think they're going to be able to blow stuff up. And we do blow stuff up, but we try to keep it controlled and as demonstrations. But here is a good example. We have some alcohol and we are going to react it with oxygen and get carbon dioxide and water. So I already drew the skeleton of the reaction. So we do need to go through and balance it. I have 2 carbons here, so I'm going to put a 2 in front. And let's leave the oxygens for last. Let's do our hydrogens. So over here I have 6 hydrogens. Now they're not written together because they write the formula to show what it looks like. And it looks like this. Okay, if I can sketch this out, this is an organic molecule. So we have 2 carbons and we have 5 hydrogens around those carbons, and then we have an OH group at the end. And this OH group, this is an alcohol group. Okay, so when you take alcohol and react it with oxygen, and you might need a little bit of a spark to get this going, you will get carbon dioxide and water. Let's go ahead and finish balancing it. So we have our hydrogens. We have 6 on one side, so I'm going to put a 3 over here. And that gives us our 6 hydrogens. Let's look at our oxygen. So we have 1 plus 2. There's 3 oxygens there. And on the other side, I have 4 oxygens plus 3 oxygens. So I should have 7 oxygens total. So I'm going to put a 3 in front of there because that will give me 6 plus 1. That will give me 7. So this is balanced. So in combustion reaction, usually there's a lot of heat that's involved too. So you really could add heat as part of the equation. So plus heat. So let's look at these 6 equations and see if you can classify them. So go ahead and stop the video and go through and classify them. Okay, we're back. So number 1, we're looking for a pattern. I see 2 compounds combining, and I get 2 new compounds. So I'm going to guess that this is double replacement, and it is. So we have our 2 metals here are switching places. So that's double replacement. Let's look at this next one. So we have carbon and hydrogen plus oxygen. And look, there's our CO2 and water. If you have those 3 things and only those 3 things with your hydrocarbon, we know that this is our combustion reaction. Looking at the next one, I have a element plus a compound, and my element kicks out the cation in the compound. So this is single replacement. Looking at this next one, I have a compound plus a compound. I get 2 new compounds. So we can see that they're switching places here. This is a double replacement. Looking at the number 5, we have 2 things combining together. So this is synthesis. And number 6, we have 1 thing that's breaking up into 2 things. So this is decomposition.